In this example, we're going to solve this separable differential equation. So it looks like I have a dy dx on the left, and I have a 3x with the square root of y on the right. So I'm going to go ahead and divide both sides by that square root of y in an effort to get the y's together. And then I'll also multiply by dx in an effort to get the x's together. So when I do so, lots of stuff will cancel, and it looks like I end up with 1 over the square root of y dy equals 3x dx. Okay, well, I'm ready now to integrate both sides of this equation. This 1 over the square root of y could be rewritten as a rational exponent. So I could say it's the integral of y to the negative 1/2 dy. And that will equal 3/2 x squared plus c when I integrate that right side. Okay, so let's go ahead and integrate the left side now that I have it easier to work with. So I'll add 1 to the power, so adding 1 to negative 1/2 gives me positive 1/2. But then I'll divide by that new power, so dividing by 1/2 is really multiplying by 2. So it looks like that. And I can divide everything by 2 to kind of get that y started to get by itself. So it looks like 3/4 x squared plus c over 2. And then let's go ahead and square both sides to get that y all by itself and write this thing in explicit form. So square the left, square the right. Looks like we have y equals, okay, so 3/4 x squared plus c over 2 squared. And this is a fine answer. You could also kind of get rid of some of these fractions here. So you could factor out a 1/4, but of course you're factoring out a 1/4 squared. So another way to write this would be y equals, and then your 1/4 squared is 1/16. Your inside now is 3x squared plus 2c quantity squared. So this would be another way to write that if you kind of are trying to get rid of the fractions inside the parentheses. But again, these two expressions are equivalent.